Right, so here's another perimeter and area type problem. So here from the figure, we can see that we have a parallelogram ABEF. So let me just indicate that right here, which is overlapped with a right angle triangle ABC to form this figure right here. It is also given the dimensions. So we have BC is 18, AB is 15, the perpendicular distance from D to AB is 10, and the height of the parallelogram is 14. So from the figure, we need to find the areas of triangle ABC, ABD, the parallelogram ABEF, and then after that we need to find the area of the whole figure as well as the perpendicular distance from D to BC. Alright, so first things first, we need to solve part A, which is pretty straightforward. So for part 1, we need to find the area of triangle ABC, which is just simply the half times its base 15 times its height 18, which then simplifies to 135. Similarly for ABD, it will be just a half. It will be a half times 15 times 10. That will be 75. And finally for the parallelogram ABEF, it's just the base of the parallelogram times its height, which will be 15 times 14. That will be 210. Now finding the area of the whole figure doesn't look that simple at first, since we have overlapping plane figures right here. However, if we take the area of the parallelogram ABF, so 210, and then we add it with the area of triangle ABC, we get seemingly like nearly the calculation of the whole figure. However, only one flaw is that the area ABD right here is counted twice, so then we need to subtract by one of them. So we need to subtract 75 from this. This will leave us with an answer of 270. And finally, the way I would solve part 2 of part B is to calculate the area of triangle BDC, which is by simply just subtracting the area of the whole figure by parallelogram ABEF. By doing that, we're left with our needed triangle. So that means the area of triangle BDC, that will be just 270 minus 210, or 60. Now since we're left with this, we can suppose a little bit of algebra right here. We can suppose the perpendicular distance from D to BC to be, let's say, x. Now we can relate x with the area of triangle BDC by forming an equation in terms of x. So hence we have 60, the area of this triangle, is equal to a half times its base 18 times its height x. Solving this, we get that x is equal to the fraction 60 over 9, which ends this video.